All right. So what we're going to do today is again re-practice some circles and re-practice a little bit of the generic geometry. I feel like the generic geometry, like what's the area of a triangle, is so straightforward. I don't want to really spend time practicing that. And hopefully we finish up a little bit quickly. All right, first one, let's find the circumference. Again, you will get the formula. The circumference is 2 pi r. You might also call it pi d. So this 12 right here, and I'll try to make clear what each measurement is. This 12 right here represents the diameter, dB. Because that represents the diameter dB, that means that the diameter is 12. So I could just do pi times 12 or 3.14 times 12. And I just want to point out, let's say you didn't realize that 12 is the diameter, or like you want to use the radius. You will do 2 times 3.14 times the radius, which is half of this, which is 6. But notice 2 times 6 causes you to have 12. So I'm just showing you, you don't have to do both. I'm just showing you that they're the same formula. There's something really special about them. So this is you do 12 times 3.14. So that's 37.68. 30, I'll put it here, 37.68. Very straightforward, very simple. Okay. Next one, they're looking for the length of JK. So when I'm looking for the length, that is the arc length. So I'm looking for how long this piece of line is. Okay. So the equation for this is the arc AB. I should say I put a little m for like the measurement of the arc AB, is always going to equal the theta over 360 times the circumference. Because we're looking for the edge of the circle, we're going to use circumference. If we were looking for a shaded area, we use area. Okay. One issue though, we only have the radius, we don't have the circumference. So we're going to have to take a little detour and find the circumference. So the circumference equals 2 pi r. So the circumference equals 2 times 3.14 times 7. So the circumference is 14 times 3.14, 43.96. 43.96. So now we have the circumference, and the theta is always that angle. So
is it 5 by 360 times 43.96?
Excellent. Yeah, we're going to take that and just plug it into the calculator. I'm just going to write it out here so we have it for reference. And I literally just go to my calculator, and then I do times 75 divided by 360. And I think you should get, well, again, we're going to do 2 decimal points. So 9.16. Technically it rounds to 6. If you put 0.5, I'm not going to take points off. Okay. But to properly round, it should be 9.16. So that's how long this little piece is, 9.16. While the whole thing overall is 43.96. So the whole circle is 43.96. This little piece is 9.16. Okay. I'll keep it up there. Next one, we're going to need to find the radius. So we got a little bit of a reverse problem. Seems like we have the arc length of EF. So this is EF in this case. So EF equals theta over 360 E times C. So in order to find the radius, we're going to need to find the C first. In order to find the C, we're going to use this equation. So 9.5 is my little arc length. So 9.5 equals, I have my theta, which is 120, over 360 times C.
So you would flip it. So you do 360 over 120 on both sides. Then you do 360 over 120 times 9.5, and that would be your answer.
Excellent. So that's going to give you the circumference. So you're not the final answer, but it'll get you closer. So this will cross out. This you'll multiply out. So that should be 18, 20, 28.5 equals C.
You just times that by pi.
So this is C, right? And then I'm going to have to use my other equation, which is C equals 2 pi r. I have my C, which is 28.5, equals 2 times 3.14 times r. Going to have to
So
multiply
divide
this out.
6.28 on both sides.
Yeah, you're
And
going to
that
take that and divide it on both sides. So and that 6.28 should feel familiar. That's going to pop up when you do these kind of reverse problems. 6.28 on both sides. This one I can't do in my head. It's going to be 4.54. So it's going to be 4.54. If you round it properly, if you put 4.53, I'm not going to take points off, but it is a little bit improper. Right, so those are your like straightforward circle ones, pretty straightforward if anything. Let's go to the next set. Let me see, actually, I'm going to do this. I'm going to bring them to separate pages so I actually have space. So let me do it like this. So I'm going to go to the next page and just post a blank one. Here we go. Okay. So I'll do this one at a time like this. A little bit more space. All right. So this is number 4. Or was this number 4 or number 5? Yeah, number 4. We're looking for the shaded region. Typically, you're always looking for the shaded region. But we're looking for the shaded region. Since we're not looking for just the outside, but the area on the inside, we're going to modify our equation a little bit. The arc of UV, or I should say the sector of UV, so we put the little piece of slice, equals theta over 360 times, since we're looking for an area inside the circle, we're going to put in area. So in order to do this, though, we need to find the area of said thing. So area equals pi r squared. Again, you do not need to remember equations, so you can just type that in, or you'll have the equation. So area equals 3.14 times 9 squared. Remember, 9 squared is actually 81, not 18. So 81 times 3.14, 254.34. 254.34. Okay. So we got the area. And we already got the theta here, which is 80. So UV is going to equal 80 over 360 times the area, which is 254.34. We're going to slap that into the calculator. Times 80 divided by 360. And that is going to equal, I can move my thing, 56.52.
There's trouble. Let's say if the 9 is on the outside, you'd subtract, correct?
If the what is on the outside?
The 9. If it wasn't in the circle, if it was outside the circle, you subtract it.
Like if the 9 was here?
Yeah.
No, what you're kind of thinking about is instead of, let's say I didn't give you 80, let's say I told you the white part over here was, let's say what would it be, 360, 280 degrees. Like I told you the white angle is 280 degrees. You would need to subtract to find this theta over here. So that's where the subtraction would come in. So it'll be 360 minus 280. And that would give you 80 degrees. So then you have the proper theta. That's would be the subtraction that would occur, okay? And that's just to find the theta. Okay, I'm gonna get the next one ready for us. Cancel. Number 5. I'll just do it on the page. There. Okay. Okay. This one's the same exact process. We need FD. The FD. Theta 360 times the area. But we don't have the area, so we're going to find the area first. So area equals pi r squared. Area equals pi 11 squared. So equals 3.14 times 121. $379.94. Please don't forget a calculator on this test. You will not be able to do it by hand. I can't do it by hand. Don't forget a calculator. So FD equals 360 on the bottom. We already got our angle. No need to find it. 135 times 379.94. We're just going to follow the steps on the calculator. And that should get us 142.48. 142.48 equals the sector of FD. I'll leave that up there so you can copy as I set up the next one. Okay, I'm going to move on to the next one, which is number 6 on the page. And I purposely picked this one just to show you a concept that works not only with rectangles, but with circles. So if you remember, when we do this with a rectangle, you'll take the outside or the bigger shape and subtract it from the inside, which is the smaller shape, if you're looking for the shaded area. Okay. So let's look at what would the outside be? Well, if this piece is 13 and this piece is 3, the radius of the bigger circle is not just 13, but the radius of the bigger circle is added together 20. So the bigger what's up?
How do you know the inside is 3?
3. I don't know the inside is 3, but I know the inside is 7 from here. This part should be 7. And then this part should be 13. So if you add it together to one big line, should be 20, no? So we're going to do the bigger circle, right? So we're going to do 20. Well, it's a circle, right? So area equals pi r squared. So 3.14 times 20 squared. 20 squared, by the way, is 400. Type that into your calculator, or I'll type it into my calculator. 3.14 times 400. Nice clean number of 1256. Okay, so I got the bigger shape. The smaller shape in this case, which is another circle, kind of looks like a donut in this case, is 7 centimeters. So that means the radius here is only 7 because it's only this piece, not the bigger piece, just the smaller piece on the inside. So 3.14 times 7 squared. And 7 squared is 49. 153.86. I'm gonna read that lined up so it looks a little bit more neater. 153.86. I'm gonna put 0.00 here if you're gonna subtract it by hand, but since you've been using a calculator the whole time, there's no shame of using a calculator. So I'm gonna use a calculator to subtract that to get my final answer. And that answer is gonna be 1102.14. So this dark area over here, the shaded, is 1102.14, 1102.14. The whole thing, if you had the full big circle, would be about 1200, and that little white circle is 153. And I'll leave this up here so you could copy it down as I prepare the last problem for today. Okay. Let me unpause. All right. For this one, we have done many of these before. So what I'm going to do is leave this for you. This is your exit ticket. So do it out. Try your best and then send me your answer. I'll give you the okay to go. And if you don't get it right within, let's say 5 minutes, maybe 4 minutes, I don't know how long this take. But if you don't get it right in 4 minutes, you just stay on and let me explain it to you. Okay, Google, set a timer for 4 minutes.
All right, 4 minutes, starting now.
Okay. Yes, you could use those numbers. Sure. Julie, you got it right. You're free to go. Ooh, you're all coming in at the same time. Nice, nice, nice. Let me check real quick. Julie got it. What's this? Sohar, you're good to go. Walner, you're good to go. Shaul, you're good to go. Angela, you're good to go. All you guys have a wonderful day so far. You too, Shaul. Again, try your best at this. If you don't get it in 4 minutes, there's nothing wrong with that. We'll just go over it together. Lael, good job. You're free to go. No, Kira, that's definitely too big. Are you sure when you cut it into the two pieces, you're using the right numbers for each piece? You might be using like the full set at one shot if you're not doing it carefully. So check your, like, how big your box actually is. You might be taking, like, if you cut it vertically, let's say, you might be using 13 instead of 8, let's say, or something like that. You're getting closer, but it's not, that's still not the right answer here. You're using 11 twice, possibly? Is that what's happening? I'm not sure. Okay, Google, stop. All right. Okay, so I'm gonna just resume the pause. I already have the work here. So I just want to make sure it's clear. This is only 5 wide, while this is 25 tall. So I did 5 times 25 here. Well, this one is only 8 wide because I'm only taking the 8 wide here. And this one is 14 tall because I'm only taking the 14 here. So 8 times 14, I got it there. And remember how I get these numbers, like 5 over here. If this is 13, then 13 minus 8 should be what's left over, which is 5. And if this whole thing is 25, 11 minus 25 or 25 minus 11 should be 14. I'm going to stop recording.